Hi there, I'm so excited to have you here again. Let us take a look at this question. This is a quiz that was shown in the previous question, okay, and this particular quiz is to throw more light on the previous video, all right. So let us start. An aeroplane flies from town A at 20 degrees north, 60 degrees east to town B, 20 degrees north, 20 degrees east. 1. If the journey takes 6 hours, calculate correct to 3 significant figures the average speed of the aeroplane. 2. If it then flies due north from town B to town C, 420 kilometers away, calculate correct to the nearest degree the latitude of town C. So if you notice in this question, you will see that the first question asks us to calculate for the average speed of the aeroplane. I think we saw that in the previous video. And then the second question says the aeroplane flies due north. Remember in the previous video it was due south. So you can see the similarity between this question and the previous question, but there's just going to be slight changes. Okay, so that's why I brought these questions so that we can solve it together. All right, so let us start. Okay, we've read that. So having read that, let us now depict that on a diagram. So you always draw this. Okay, particularly since it's going to be a theory question, you have to draw this. Even if it is an OBJ objective, so you have to draw that. So remember that this is the north and this is the south pole. This is the west and this is the east. Good. So let's go for the first town, which is located at 20 degrees north. Remember that this is the equator and it rises up until 90 degrees. So it's just going to be a little bit above the equator. So this is 20 degrees north. Okay, then for the longitude, which is 60 degrees east, all right, so that also will rise from the Greenwich meridian. There is an imaginary line that is cutting from the North Pole to the South Pole. So it goes up until 90 at this face, then another 90 just behind this ball. Remember, this is a globe, like representing the world. Okay, so this is going to be around here. We're talking about the 60 degrees east. So this is 60 degrees east. All right, so for the next town, the location of the next town we're told is 20 degrees north, which is the same as the previous latitude. Then 20 degrees east, that will be close to the equator, just 20 degrees away, from the Greenwich meridian. All right, so this is 20 degrees east. Then the latitude is still 20 degrees north. So this is town B, and this is town A. Okay, good. So let's work on the first question. So the first question says that we should calculate the average speed of the plane when it flew from A to B, and it took 6 hours. Okay, so the first movement that happened along the parallel of this latitude, the longitudinal difference is equal to let's say theta, and that is equal to 60, okay, minus 20 degrees. It moved from 60 to 20, so the difference between the log is equal to 40 degrees. Okay, so having said that, then the radius of the earth, as we know, is 6,400 kilometers. All right, good. So now let's calculate the distance traveled. The distance traveled from A to B. The distance traveled from A to B is equal to, we have the theta, which we've got in here, which is the log difference, that is 40 degrees, to be divided by 360 times 2 times pi, as given in the question, 3.142. Good. Then times the radius, okay, and the small radius is equal to the big radius, that's the radius of the earth, times cos theta. So that is what we are going to have here. So the radius of the earth, as given in the question, is 6,400, then times cos. What are we looking at? We're looking at the latitude, 20 degrees. Okay, so if you punch these in your calculator, this is what you are going to arrive at: 4,199.13. So that is the distance traveled. The question says we should look for the average speed. So since we know the distance traveled, we can calculate the average speed, which is the formula, distance traveled 4,199.13 to be divided by the time it took, which is what? 6 hours. Good. So our calculator will give us our final answer, 700 kilometers per hour, and this is to 3 significant figures. Okay, good. So next, let's take a look at the second question. The second question says the aeroplane now flies due north, so that means it will go up. All right, so it flies due north. So we have another brand new latitude. So this is to form another location C, and it took 40 kilometers away from B. All right, so we are to calculate the latitude at C. So for this now, we don't know what this is, so that is what we want to calculate. So we're still going to use the same formulas that we've been using. The length of an arc. So the distance traveled, we're told, from B to C is 420 kilometers, as shown in the question. Then for the difference in the longitude, we don't have that, so let that be represented by theta again, to be divided by 360, then times 2, then times pi, which is giving us 3.142, then times the big radius. Okay, so this time around we just have the big radius, 6,400. So if you punch this in your calculator, we have theta equals 3.76 approximately. We have not yet arrived at the longitude. So the latitude, we're talking about the latitude, sorry. This is the latitude. So the latitude of the town C is equal to, remember, it's going up, so we're going to add to 20 degrees. So remember in the previous question it was going down, so we had to subtract, but this time around it is going up, so we have to add to it. All right, so we're going to add 20 degrees north plus 3.76 degrees north, and that will give us 24 degrees to the nearest degree, and this is to the north. So that is the latitude of town C. I hope this helped. Good. See you some. Thank you for watching. See you some other time. Bye for now.